Alright, so today we are doing the percent composition lab, and it's going to be using a crucible. So when you look at your data, there should be a mass of the crucible by itself, and then I would ask you if you're in class, we're going to add about 0.5 grams, about half a gram. So notice I'm at 14.58, so I'm going to add this until I get to around 15. So a little bit more. Oh my goodness. Okay, there we go. That's going to be close enough. So 15.02. So look at your data. Don't use these numbers, but use your data. So the next thing we're going to do is direct your attention over here. All right. There we go. So I'm going to light my Bunsen burner. Open this up on the bottom. Light it. Should have yellow flame. I'm going to adjust it so that I can get to some stuff that got dropped in there when we did our flame test lab. So kind of light blue, dark blue. I'm not sure you can see it in the light. But the next thing I'm going to do is, this is called a wire triangle for obvious reasons. It's a wire triangle. And I'm going to stick my substance up here. And essentially at the very beginning, I'm just going to kind of slowly heat it, kind of back and forth. I might be able to grab the camera and have you kind of look in here. But what's going to happen is, I'm not sure you can really see in there. I'm heating it, and essentially what's going to look like, it looks like it's boiling, but it's not going to actually boil because there's not water in it. It's potassium perchlorate. I kind of talk about the lab whenever we're waiting for this to kind of just heat up and cool down. But as I heat it, I'm just going to, again, get that blue flame right on the bottom. And there we go. That's probably a better angle. So it kind of looks like it's melting. It's not. I'm just getting all of the oxygen that's kind of trapped in that ionic compound to come out. So I'm evaporating out the oxygen. And even though it looks like a liquid, it's going to re-solidify. So I'm actually just going to take that back and just set this back up over here. And is that something you can see? Yeah. So we're just going to set this flame under here and let it go for, I don't know, 2 or 3 minutes. So I'm going to pause this for now. And we'll come back in a sec. So if I can kind of focus in there. So it looks like it's boiling. It looks like it's boiling, but there's no water in this reaction at all. So it's just simply the oxygen that's trapped in the compound itself that's coming out, kind of just evaporating out. And it's going to kind of boil like that. It looks like it's boiling, but it's just bubbling as the oxygen is coming out. And like all of a sudden it kind of just stops. And there it goes. It's kind of just done. So I'm going to let it stay heating for about another minute or 2 minutes just to make sure I get all the oxygen out. Alright, so it's been heating for another about 2 minutes since we last kind of saw what looked like the boiling, which wasn't really boiling. So these are Crucible Tongs, and for obvious reasons they are used for crucibles. So I'm going to grab the crucible and then just set it on the table. I'm going to turn my heat off. And we're just going to let this sit until I can pick it up with my hands. Things that are hot tend to not weigh correctly on the scale. They actually weigh less than they should. So we're going to let it cool down, and once it's cool, I'll come back, we'll weigh it again, and that's basically the procedure of the lab. So once you log in and look at the data, you'll see exactly what the data shows, and then kind of once we have that, I'll go up to the front and just talk through the lab a little bit, so you kind of have an idea of what you'll be doing calculation-wise with the numbers you collect. Alright, so this is now cooled off, so I'm going to stick it on here, and our weight should have gone down a little bit, so we're back at 14.85, because I started with potassium, chlorine, and oxygen, and I boiled, not boiled, but I drove all of the oxygen out. So now I only have the potassium and chloride I started with left. So now you have all the data you need to find the percent oxygen in the compound. All right, so we'll talk about the lab right now as I go up to the front and just kind of talk about the procedure, or talk about the math you will do for the lab. All right, class, so today we're doing a percent composition lab. And essentially, here is what the lab looks like. We're going to start with potassium chlorate. All right, so that's the compound name. And kind of the reaction looks like this. We're going to heat it. So we will put a heat over the arrow. And when this breaks down, we say it's a decomposition reaction. We'll learn about reaction types when we come back in January. But this decomposes into oxygen gas. Whoa, I don't know what O3 is. We're going to change that real quick. Into oxygen gas and potassium chloride. If we looked at the states of these things, this starts as a solid, and then obviously oxygen as a gas, and then potassium chloride is also a solid. All right. So when you open up the data that you're going to get, or like part of the video, you kind of saw where we measured stuff. The first thing we're going to do is get the mass of the crucible. So this is the vessel that we're going to actually put the potassium chlorate in and heat it in. And then our next measurement is crucible plus potassium chlorate. Okay, so this is going to be some number, and this is going to be some number. Okay, and then the last thing we're going to do is we're going to heat it. And notice when we heat it, all this becomes a gas. It goes bye-bye. Okay, and what's left in my crucible is just the potassium chloride. So at the end of heating, I've got crucible plus KCl. Okay, and it's going to be some number. This number should be less than that number because I no longer have the oxygen attached. So essentially, if we do percent composition, we have elements, mass, right? So mass of element divided by mass of compound. Because as you recall, percentage is always part of whole. Part over whole. So it's fairly easy to find my mass of KClO3, my entire compound, because it's going to be the difference between crucible and KClO3. Okay, the crucible mass doesn't change, so the difference in these two numbers is the mass of my compound. And then if I get the mass of these two things, the difference is because this mass got less, because the difference of these two things is the mass of my element, because my element is oxygen. Okay? So those two values will give you your mass of element divided by mass of compound. On the back of the lab, you'll actually do two calculations. The first one, I believe, is experimental numbers. So this is the experiment stuff that you got. And then the second one that you're going to do is based on the periodic table. Okay? So look up potassium's mass, chlorine's mass, oxygen times 3's mass, get that mass from the periodic table, and find out what oxygen's component or contribution to that total mass is. So just like you did on the worksheet. Okay, so that is the lab. You have the procedure. You can see what we do, where those numbers come from, and then just answer the questions in the lab and get that submitted and turned in. All right, so class, so this is basically a follow-up to the lab we just did. So the percent composition lab is potassium chlorate, that KClO compound that we started with. I've got a little bit right here. And what happens is when I decompose it, so I'm going to get this flame going pretty good. So light blue. I'm going to melt this here at the bottom. Or not melt, I guess I melted. I'm going to boil the oxygen out. And as the oxygen boils out completely, my test tube is basically going to be full of oxygen. And then I've got a gummy bear here. Okay. So gummy bear, just an idea of like the calories involved whenever we eat food. So this gummy bear, I don't know, has like 15 calories in it or something like that, maybe less than that. But you're going to see the energy content of a gummy bear. Usually what will happen is I do this demo the day after we do the lab, because I don't want you guys getting any ideas as we do the lab. But when we're making this much pure oxygen, oxygen is the major component of like fires keeping on going. So right now my potassium chloride's potassium chlorate's decomposing, and pretty much everybody gathers around the fume hood, and essentially I'm going to drop the gummy bear down the test tube, and you'll see what happens to the gummy bear. Usually we put him on trial. It's the trial of G. Ummy, and he's a bearable. That's why you've never seen blue gummy bears, because he has eaten all the blue gummy bears, which is a pretty heinous crime. So you, the people of the court, get to decide his fate, and I think we're just about good. So anyways, most people choose the slide of death. So anyways, GM is going to go down the slide of death. Here he is. So gummy bear meeting molten potassium chloride and loss of oxygen. Couple last whimpers, and there we go. Mr. G. Ummy meeting his doom. And now it smells like s'mores or burnt marshmallows here in the class. So anyways, one of my favorite demos of the year. Food has tons of calories to supply your brain with all the energy it needs and your muscles and everything else. A little bit of calories and go a long ways in terms of energy. He's still trying to breathe a little bit. All right, out.